Good evening, friends and colleagues. On behalf of the Planetary Society, I'd like to thank the citizens of Adelaide, Australia, including the first citizens of this land, for hosting this year's International Astronautical Congress. We're very inspired by your hospitality and your very generous spirit. As the world's largest nonprofit space advocacy group, the Planetary Society's mission is to empower the world's citizens to advance space science and exploration. It is my pleasure and a great privilege to introduce this evening's highlight lecture, Lightsail and Innovations in Solar Sailing.
Well, there's a just tremendously exciting prospect called solar sailing.
Solar sailing.
And this is a very crude model, and which travels on the radiation and particles that come out of the sun, the wind from the sun. And it works exactly as an ordinary sailboat does, so it can go out from the sun, it can tack inwards to the sun, and because it has a constant acceleration, it can get you around the inner part of the solar system a lot faster and a lot more conveniently than the usual sorts of rocket propulsion.
Please welcome science educator, space advocate, and CEO of the Planetary Society, Bill Nye.
You know the old saying, hello Adelaide! Ladies and gentlemen, boys and girls, kids of all ages, no, it's great to see you. Thank you so much for including us. And I also want to thank you, as a guy, you may infer from my accent that I'm from the United States. And I want to thank you for all that you've done for space exploration by building a whole continent here in the Southern Hemisphere. Everybody, I want to thank you especially for creating the Australian Space Agency. I mean, that is very... Yes, yes. But keep in mind that without Australia, without Canberra, there would not be any signal from any spacecraft. No one would even know that the space was explored without these telescopes that are part of the Deep Space Network. So I'm delighted that you have formalized your space agency, and I really encourage you, as the space agency in Australia comes into being, just to have a really cool logo. Because that's what people respond to. So there are two questions that we have all asked, and if you meet someone who claims he or she has never asked these two questions about why we explore, they're lying to you. The first question is, where did we come from? Where did we all come from? How did we all get here? What are we doing here on this planet, if I may, for crying out loud? And the other question is, are we alone in the universe? And if you want to answer those two questions, you have to explore space. And that's why we have this Astronautical Congress, to celebrate this human tendency. Now, humans have explored for millennia, and a great innovation was being able to find your way across the trackless ocean. And now we want to be able to find our way across the trackless cosmos. But I want to emphasize that it's really not that new an idea. Sailing on the ocean is one thing. Sailing through space is really an idea that goes all the way back at least to Johann Kepler, who in a letter to Galileo Galilei remarked, someday humankind will provide ships or sails adapted to the heavenly breezes, and there will be some who will brave even that void. Come on, that's romantic. That's just cool. And that's why Carl Sagan was so excited about a solar sail back in the disco era in 1976. And I was in his class. I took astronomy from Carl Sagan. Back then, my hair was a different configuration. And I have to say that we have come a long way in fashion. Those are very, very troubling times. But this vision was not realized. The idea was there was a mission proposed that was going to go out to Comet Halley. Now, Comet Halley is going very fast, and the strange and surprising thing about solar sailing in general, though I'm sure there's a lot of rocket people here, I love rockets as much as the next guy, maybe more, but solar sails work in this extraordinary fashion. The acceleration, or the impetus, comes from pure light. And you're saying, but Bill, 9. Dude, light has no mass. What sort of sick game are you playing? And we would say, nevertheless, although light is massless, photons are massless, they have momentum. Now, when Carl Sagan earlier on mentioned the solar wind, he actually misspoke. Solar sails do not really operate on the solar wind. It's a tiny fraction of the momentum in the light itself. And so the idea is that although the momentum is very small, it's about 9 micronewtons per square meter, if you're scoring along with us, it's out there pushing on the solar sail spacecraft day and night. But wait, it's in outer space, there's no night. That's right, 24/7, 365 and a quarter, there's this gentle push from sunlight. So the idea was to build this extraordinary, huge spacecraft that would spin, and the centrifugal motion of weights on the end of the solar sails would hold the solar sail blades or gores or sails out, and then sunlight would give it a push. It would leave the Earth in conventional west to east orbit, go over the North and South Pole, and then get retrograde and go out and catch up with Comet Halley. But that mission was canceled in exchange generally for the space shuttle program, which led to all sorts of other advances. But the Planetary Society was founded by Carl Sagan, Bruce Murray, who some of you may remember was the head of the Jet Propulsion Lab during the Voyager missions and the Viking missions, the first missions that landed on Mars in that heyday. And then Lou Friedman, who was an engineer on this mission. He was an orbital mechanics guy. And Lou wrote this book back in 1985. At that time, I was working at a company called Sunstrand Data Control, which is now part of Honeywell, and I was working on black boxes, getting the heat out. I know, it was exciting. And I read this book, and I thought, this is the coolest thing ever. And so Lou was the executive director of the Planetary Society, and I joined the Planetary Society when it was founded in 1980. I got a letter in the mail. Sorry, I see some young people. Okay. It was a way to store information. It was plant-based method of information storage. You couldn't do this to it. But we looked it up. I'm a charter member of the Planetary Society. I bought this book. I thought this was cool. So Lou and Carl and Bruce were working very hard to try to get a solar sail. They were never really successful. Carl died in 1996. I spoke at his memorial service in 97 because the success of the Science Guy show. I got to tell you, how many New Zealanders, gee whiz. That's it, thank you. No, that's it, thank you very much, that's it. No, I'm kidding. Charles, Matt, I'm kidding. No, I was just talking to a Kiwi guy who was taking credit for the whole thing. I'm sorry. How many Australians have seen the Science Guy show? That is just amazing, thank you. And you can understand it even with my accent and everything? Anyway, that is really surprising to me. So because Carl's kids watched the Science Guy show, I spoke at this memorial service. And I met Lou Friedman, and he wanted to do this thing. And so in 2005, the Planetary Society got enough together to build what was called Cosmos 1. And this was designed with colleagues in Russia, or the Soviet Union, former Soviet Union. And this thing was huge, huge. Much taller than this room, fully extended, and the booms, just like a sailboat boom, were going to be inflated with gas. And it was going to go in space and inflate, and we were going to steer around, and it was going to be just fabulous. But in keeping with the spirit of Carl and Bruce and Lou Friedman, they wanted to turn swords into plowshares. So we got the use of a Soviet-era ballistic missile, like you have. And there was a few of these around. They were available. And we really did launch from a submarine. I'm not that good with Cyrillic, but on the rocket it says Volna, which is the wave in Russian. And the submarine is named after a city. A Russian submarine is named after a city, and this is named, I guess you can read it, Borisovich. Now that, you see, I don't speak Russian. But this went out to sea, we launched it, and the Cosmos 1 spacecraft is in an area of the Arctic Ocean called the Barents Sea. And I presume it's still there. Just right into the drink, boom, it was done. So the Planetary Society had tried to fly a solar sail, was unsuccessful. Meanwhile, the Japanese Aerospace Exploration Agency, JAXA, just had a mission going to Venus, the Venus orbiter, which has the wonderful name Akatsuki, which means dawn or daybreak in Japanese, and along with it, our colleagues in solar sailing, if you go to the solar sailing conference, there are more than a dozen people. There's a few people, but our Japanese colleagues managed to build this enormous Icarus sail, and is very traditional in Japanese aerospace. It has a Romanji or English character named the Interplanetary Kite Craft, accelerated by radiation from the sun. Icarus, named after the Greek guy who tried gluing feathers to his arms. And then that led to some trouble. But the spacecraft went out and the sail deployed by spinning, and it had the coolest maneuvering system. They caused this sail to be not as shiny in certain quadrants with liquid crystals, which are incorporated in it. And JAXA had the foresight to have another very, very small spacecraft that was essentially a camera that went out and took a space-to-space picture. And this is this beautiful thing. Now, the bus, or the chassis, or the airframe of Icarus is quite massive. It's about 600 kilos. So this thing demonstrated acceleration and maneuvering, but it was just a demonstration. And we have a quantity that we use in solar sailing called the lightness number, and it's the ratio of the acceleration of the sun wherever you are to the acceleration provided by the sail. And the Icarus sail was about 1,000th, 0.001. And a very, very capable sail would be around, if you could build it, it would be around 0.1, about 1,000 times, about 100 times more acceleration. But along this line, the Planetary Society, after another 10 years, was able to get support from people like you. Are there Planetary Society members here? I love you guys. Thank you so much. Thank you. It's the support of people like you. We were able to initiate another program which we call Lightsail. And Lightsail 1 is a modern standard that's emerged organically in space exploration called CubeSats. I'm sure many of you are familiar with CubeSat. I don't know where they came up with this name. It's a cubical satellite. And so it's nominally 10 by 10 by 10 centimeters, this big. Ours is a 3-unit or 3U CubeSat, 10 by 10 by 30. So it's quite a bit smaller than a loaf of bread. But the premise of the bit, as we say in comedy writing, is that the sail will deploy about the area of this dais where I'm standing, out of this loaf of bread sized box. And the reason we're able to do that is the sail material is extraordinarily thin. It's about a 20th of a human hair in thickness. And it's aluminized what's called a clay polymer. It's a plastic with an alkaline group attached to the end, and it's very durable and quite reasonably priced. And so because of the low mass of the Lightsail CubeSat and the very large area of the sails, our lightness number is about 0.01. It's about 10 times that of the Icarus sail. And in May of 2015, thanks to support of our members, we were able to fly. We went to Cape Canaveral, Atlas V rocket, the venerable Atlas V, and the test mission was a success. We got it into space. We had some issues with the software, we had some issues with the cameras, but we stuck with it, and we were able to get pictures sent down with the sun in the background. And this is the first picture from a solar sail in Earth orbit. And we were very proud of it, and we learned a lot. You know, the idea is that when you get up there, you can tack, just like a sailboat, and increase the orbital energy, and then go to all sorts of destinations in the solar system much more cheaply than you could with rockets, because the fuel is free, and it pushes on the spacecraft all the time. So this summer, as CEO of the Planetary Society and the success of our first mission, I was invited to appear on the Stephen Colbert Show, which is the Late Show, which is the modern, most popular nighttime show on U.S. television. And you guys, I'll just tell you, I was quite moved. I took one class. I'm a mechanical engineer. I mean, I'm human, but I'm a mechanical engineer. I took one class in astronomy for kicks after I'd finished my engineering requirements. And this guy talked romantically about this, and now I'm the CEO, and we pulled it off, and I had our own very crude model. Did you see Carl Sagan's very crude model? It took somebody weeks. Anyway, and we were able to show him this, and Stephen Colbert is a very literate guy and another actually science enthusiast. And so it was a big moment for me. And we have built a second spacecraft that is more capable. Instead of having mass models or dummy masses for certain, for the momentum wheel, for example, the thing is full up and ready to go. And what we want to do now is demonstrate solar sailing in a more advanced way, and it's thanks to our members. So here's how you build a spacecraft nowadays. So let me emphasize that when you're in space, there's no music. There's no sound. But the idea is to be part of another mission called Prox 1, which is something the U.S. Air Force is very interested in because they want to be able to keep station with 2 very small spacecraft. And what's happened to everybody in space exploration is the instruments have become more and more compact, more and more capable. The software is being processed on more compact, more capable microchips. And we were able to do so much more in a much smaller package. And for you engineering buffs, I'll just tell you there's a couple features that are just fantastic. When you deploy this great big aluminized sheet, you have a fantastic ground plane for your antenna. The cameras were specially designed and built for us by the Aerospace Corporation, so thank you to them. The booms were built by the Air Force Research Lab in Albuquerque, New Mexico in the United States. I'm not sure the guy who did it is old enough to drive, but this is the idea. You twist using a momentum wheel, and you go edge on toward the sun. You build orbital energy just the way you would with a rocket motor. Then you twist and take full advantage of the solar pressure, the push from the photons. And you build orbital energy on paper indefinitely, or on your iPad indefinitely. And this is a very romantic and beautiful thing, and there's many, many space missions that are just ideally suited to this. For example, monitoring what people call solar weather, coronal mass ejection from the sun. You could be at an inferior orbit. You could be around 7 AU, the orbit of Venus, and keep station with the Earth. If you want to look for asteroids in particular parts of Earth's orbit, you could have a constellation of these. And the solar sail would keep it there in a way that would be absolutely impractical and not affordable with rocket motors. Then there's other ideas to get above the Earth's North Pole and monitor the weather on the Earth using energy from the sun to keep station indefinitely, as long as the sails last. And the other thing is, by doing it, by using CubeSats, it enables universities and smaller organizations that want to fly satellites to get up there and take them to all sorts of destinations in the solar system. We are working at the Planetary Society to democratize space. And the team that does it, let's see, is here. Some of them are seated here in the front row. Dave, John, Jordy, they're here and they're smiling because it worked. So by the rules of the game, this is a reasonably clean room. The signal goes from the spacecraft to another building at Cal Poly, California Polytech Institute in San Luis Obispo, California. Yes, where everybody knows how to surf, yes. And then it goes back to the spacecraft in this room. And something must have gone right because everybody's smiling. And we're ready to go. And part of what we do, you can see it here, we put a compact disc, a DVD, digital video disc, on the spacecraft. And we have found from the last 37 years that people love to send part of themselves into space. There's some human nature thing. There are thousands of signatures of members on Mars, on other spacecraft, and we provide the opportunity for people to participate here by putting their what we call selfies to space on this special ceramic disc that is a spacefaring disc as long as the spacecraft is on orbit. And people sent us their pictures, and you don't have to join the Planetary Society. There's no financial obligation. People do it because it just appeals to us. There's something about our human nature that wants to fly in space. So the Planetary Society is here for you. Send us your picture and we will fly. We are on the manifest. We're ready to go. And we are very excited also because the manifest I'm talking about is for the second Falcon Heavy. Now, this is the day in the life test where we deploy it. It is interesting to note that although the spacecraft is only this big, there is no thermal vacuum chamber available to deploy all 4 sails and test it. So this is part of the presumed risk. What if there are bubbles in the folded up, in the crinkles? What if the bubbles burst and the sails rip? And so, well, they don't. We figured out that it works. And so we just deploy it on this very smooth, very flat table, and it works fine. And you get a scale, you get a sense of the scale of how big the spacecraft is relative to the people in the background. When it works, you guys, it's very exciting. And you can imagine, you can see the texture in this picture. The stuff, when you buy it, is just very flat, like a mirror. And don't worry, some of US tax dollars have been expended measuring the effect not only of wrinkles, but also crinkles. Crinkles and wrinkles have been assessed. And you can imagine, the light comes in, if the surface were perfectly flat, the light would go straight out. It's, if I may, a cosine function. But since there's wrinkles and crinkles, there's a little bit of a loss of efficiency. What is that? It's hard to assess in a room like this because we're not in deep space. We don't have thermal issues, no vacuum issues. But I hearken to the words of Boeing test pilot Tex Johnston, who was famed for doing a barrel roll with a 707 airliner. And he said, "One test is worth 1,000 expert opinions." And so that's what the Planetary Society provides you, is this test. We advance space science and exploration. And so we are very excited to be part of the second Falcon Heavy. SpaceX is required to fly one to prove that it works, and then we're on the second one. And so the Falcon 9, anybody know how many engines the Falcon 9 has? I'm going too fast. Falcon 9 has 9 engines, and the Falcon Heavy's first stage is 3 Falcon 9s strapped together. It is a big rocket, and we're thankful that our little spacecraft will be able to be carried aloft, and we're waiting for the ride, as we say. Now, our mission is to advance science, to advance exploration. So along that line, you may know that there's an upcoming NASA mission called the NEA Scout, Near Earth Asteroid Scout Mission. And the engineers there have decided that a solar sail really is the best way to augment it. They can't get more than 1 astronomical unit from Earth to keep in communication. And we strongly believe that the sails will be the right way to go, and they're using a deployment mechanism very similar to ours. And when you go to the Solar Sailing Conference, we're all there. "Hey man, it's great to see you." All 12 of us. And also, you may have heard about this extraordinary idea called the breakthrough Starshot, where you put a solar sail in space and then blast it with a laser to push it to another star system. You know, the way you do. And then we presume the other star system watches it go by. Because if you give that much energy to even a small spacecraft, it's going to have a fraction of a large weapon in momentum, in kinetic energy. So it's cool, but let's make sure we think this through. But we are charmed that the Starshot people chose to use a very similar design to our solar sail, our Lightsail, for their first cut. We don't know where they're going to end up, but that's their first idea. So we are democratizing space. We are providing this technology to as many people as would want it. And that number, 216 million kilometers an hour, is their calculation based on the amount of energy you give it. I mean, that would be moving. You know the old saying, you're supposed to be able to stop a locomotive with a mosquito if the mosquito's going fast enough. This is maybe along that line. So we like to say we're democratizing space. Technically, the Lightsail program is a technical thing where we did a whole bunch of technical innovations that were at first proprietary. We solved, to me, a real interesting mechanical problem that had not been solved before. People may know about the NanoSail D mission, which had a deployment mechanism, and it was going to drag spacecraft down on purpose to deorbit them and stuff, but the sails didn't deploy for 5.5 weeks, and they probably deployed because of thermal action between going light and dark around the Earth. But our engineers solved that problem, and they also found a way to get the antenna to work better, and we solved a lot of cool little problems. But the other thing that we do at the Planetary Society to advance space science and exploration is policy. We have 3 full-time policy people that go especially to US Congress. To a limited extent in Europe, a limited extent in Japan. We hope to work very closely with the Australian Space Agency, and we establish relationships that enable us to promote what we think are appropriate space policies. There's an old saying, Washington, D.C. is a small town based on relationships. So what you do is become friends with congressmen and senators and staffers, especially, and explain to them what they want. And then what we do is engage our members. We have over 50,000 members in over 100 countries around the world. And from time to time, we engage them to lobby, actually that's an official word, to advocate with their representatives in the United States and elsewhere to get various missions funded. And I went, when I was so-called vice president of the Planetary Society, I went to Senator Barbara Mikulski's office twice, in 2000 and then again late in 2001, I guess 2002. And we went in with about 10,000 postcards from our members and encouraged her to fund a mission to Pluto. Now that's the mission that became New Horizons, and as you may know, this thing sent back this extraordinary picture. We were there in 2002. In fact, one of the guys with me was James Cameron, the guy who did the Titanic movie, Avatar. And by the way, he's going to direct another Terminator film. Look forward to that. But he is a real space enthusiast, and we petitioned the senator, and she got it funded, so the spacecraft was built, started, I guess, around that time, 2002, it launched in 2006, and a quick 9.5 years later, we got this picture. So when I was a kid, I had a poster of the solar system that showed Pluto with all these icicles and icebergs and stuff. But the real picture is much cooler than anything we imagined. At least 7 geological regions, crater impacts, evidence of all kinds of ices, and it's just one of thousands or tens of thousands of similar worlds. So this is something that we take a lot of pride in, is these missions take a long time. Planetary missions takes a long time because there is a lot of space in space. And I'm happy to say that we also petitioned very strongly to get a mission to Europa. And for those of you, I see a lot of kids here, Europa is a moon of Jupiter with twice as much seawater as the Earth. And if you have twice as much seawater as the Earth for 4.5 billion years, maybe there are Europanians swimming around. Europanian fish people speaking Europanian and doing all sorts of Europanian things. And their idea of the sky is quite different from ours because the sky is just ice. And you know, there are fissures where we're pretty sure jets of seawater get blown into space. And you can't help but wonder, do the Europanians have jokes, about, I hope I don't get near one of those jets, whoa! And you fly into space. This mission is called Europa Clipper, and it's now in phase A. We're very excited that long about 2023, we hope that we launch it and we will make extraordinary discovery. I claim, people, that if we were to find evidence of life on Europa, on Mars, somewhere in the solar system, it would change the world. It would change the course of human history. I mean, we wouldn't change everything. I think here you guys would continue to drive on the left. But it would be profound. It would change the way each and every one of us thinks about what it means to be a living thing in the universe. It would be extraordinary. And we do this for an extraordinarily low amount of money. I mean, compared to the amount of money we spend, any space agency spends on anything, it's planetary exploration is a bargain. The whole thing is getting those instruments figured out and getting those instruments out to the destinations. So we're very excited about the Europa mission. And if you want to support it, check out planetary.org and you can stay abreast. One of the things we did that was very well received with the Lightsail spacecraft is we didn't hide our problems. We put them online and it gave the mission drama, which it already had, but it enabled people to follow along because it was a struggle to get this new style of spacecraft in space, and we did it, everybody. The first spacecraft it's difficult to reckon, but a little over $5 million. The second one, for all included, both programs, Lightsail 1 and 2, for a little over $7 million. And that is a very low figure compared to what it often costs at regular space agencies. And it's more risky, but it's also entrepreneurial, and it worked. So along this line, we promote advocacy in many different forms. I was at the Australian Embassy with my new best buddy, Anthony Murfett, who's the Minister Counselor for Industry, Science and Education. I got my mateship pin, and we talked about space exploration, and I'll tell you people, I'm no detective, but Anthony, I call him Anthony, he had a gleam in his eye, and I think he knew that Australia was about to announce an official space agency. And as I say, I hope it's just a really cool logo. So along this line, we had a great meeting there. This was about 2 weeks ago in Washington, D.C. at the embassy. And now we're here at the IAC. But earlier this year, we were a partner in the Global March for Science. And I'm very proud of this. As you may know, there is deep concern that science is being marginalized, is not being funded the way it was, especially in the United States. There's concern in other countries, of course. But science is how we innovate. And innovation is what leads to economic competitiveness. You cannot compete on the world stage in the developed world without science. So we marched, there I am in Washington, D.C., but there were many, many marches around the world, including about a dozen in Australia. So it was an exciting thing for everybody in the world to be part of. And we were partners in that because this mission is deep within us. As we like to say, science is universal. Now, we had the extraordinary event in the United States. In August, on the 21st, we had a total solar eclipse, which went right across the third most populous country, world's third most populous country, the United States. And so the Planetary Society was part of that. We had our own official eclipse classes. I went to Nebraska, the state in the middle of the United States, to be in the path of totality. And although the eclipse was this eclipse was in the United States, it engaged people around the world. Because this eclipse was not way out at sea, it was over a populous country with an interstate highway system that enabled people, thousands and thousands of people, millions of people, to get in the path of totality. And that was exciting, and it reminded everybody of the importance of space exploration. Understand that astronomers predicted that eclipse within fractions of a second. We take it for granted, but that is a result of centuries of space exploration. That is a result of centuries of science. And I'd just like to remind everybody that when we were able to predict an eclipse and see it, and see the extraordinary details of it, it is a reminder that space exploration brings out the best in us. Space exploration is inherently optimistic. People were joyful at the beautiful sight of the eclipse because we were able to predict it and be there and share it. It was an extraordinary day, and I look forward to, I don't know if I'll become a real eclipse chaser like some of my friends, but I do look forward to my next one. So we hold events with our global volunteer network, and people come who love space, come to celebrate it. We have star parties with telescopes, we have lecture series, we have members of our board are extraordinarily accomplished space advocates and explorers and historians, and we get together, and Elon Musk is in the picture. Are there any professors here? Any professors? I just want you to know, when you use a laser pointer and you shake it, it doesn't help. Okay, I know you think you're emphasizing, but it doesn't help. But Elon has been a long friend of the society, and he was on our board for a while, but he recused himself when he started selling rockets, and we're on we're on SpaceX's Falcon Heavy. It's going to be an exciting time. And gatherings like this are what we do. It's what the Planetary Society does. And for those of you who have participated in some of our star parties and space events and planet fests, we thank you all. Everyone can participate, everyone can be there, and everyone can share in what I call the PB&J, the passion, beauty, and joy of space exploration. So now I'd like to thank you all for coming and remind you that we are living at an extraordinary time. We know the cosmos in a way that our ancestors couldn't even imagine. We know our place in space in a way that no one before us could know it. And that to me is amazing. And I think about my grandfather, who grew up with no knowledge of relativity. No knowledge of it. My father came of age when relativity was discovered. And now I think most of the people in this room can't tell which side of the street they're on without looking at their mobile phone, which depends on both general and special relativity. So now we have discovered dark matter. And it is not an extraordinary thing to predict that in a decade, 20 years, 2 decades, some discovery about dark matter and dark energy will be made that will be profound and change the course of history. And we are all part of it today. And so I am very excited to be here in Adelaide with you all. So for now, I'd be very pleased to take your questions. Thank you so much for coming. There are private companies, but at the bottom of all of this, whether you work at a space agency, you work at a private company, or you're a citizen that enjoys space exploration, it's the citizens that drive us all. It's the citizens. So thank you. Please come down and we'll take questions. There's people with microphones. There's one right there. Who's got a microphone? Oh, there's Guy in Blue. Guy in Blue. That's not his real name. Yes, sir.
So I wanted to ask that most of us in the space community, we emphasize on space debris. So,
space debris.
Yeah, and we emphasize on deorbiting devices, and most of the deorbiting devices are like parachutes.
Yeah, parachutes, yeah.
So you are deploying a sail. Doesn't that induce any drag? I mean...
So that is a feature. When you deploy, for example, Lightsail 1 was deployed at a low enough altitude that it was dragged down. There's a few molecules, not so many that you'd notice, if you take off your helmet, but there are enough air molecules to drag it down, and that's one of the applications of our deployer mechanism, is to put deployer mechanisms on spacecraft to drag them down on purpose when their useful life is done. Does that answer your question? So Lightsail 1 was dragged down, it's not in orbit anymore.
How did the Lightsail 2 perform?
Say it again?
How did the Lightsail 2 perform?
How long did it last?
Yeah, did we get the acceleration we actually wanted?
Oh no, so that's what we're going to do with Lightsail 2. Lightsail 1, here's the problem, you guys. We are a secondary payload. You get on the manifest, you apply for this thing called educational launch of nanosatellites. And when there's a ride, you take it. So we took it with our first spacecraft in hopes of learning things, and we did. We're very excited about LightSail 2, which will have the ability to tack and increase orbital energy. So that's a great question. Yeah. LightSail 1 was, we are victims, man, of being a secondary payload. I see a question up there. No, yes? Oh, here, okay. But then we'll get guy in red after guy in sweater.
Bill, at the risk of going back to politics, how can we prevent this retraction from science that we're seeing in the US and globally?
How can we prevent it? Well, join the Planetary Society. We march to remind our congressmen and senators and people and your members of parliament that science is important. And demonstrations are very effective. I am of an age where I remember the demonstrations against the Vietnam War, and they were effective. Just remember, when you march one day, they don't change overnight. But if we keep the pressure on politically, people will come around, I think, because just the economic importance of advocacy, the economic importance of science and basic research. I am so old, how old are you? I remember when the laser was a discovery without an application. The word coherent light was invented when I was a kid. Now, what doesn't have a laser? My pen, maybe. And actually, there are pens with lasers. So we'll see what happens in the coming years, but we got to keep the pressure on. And for Australians, with your new space agency, I'll just tell you from our experience I grew up in the US, NASA is the best brand the United States has. There are people who like the United States. There are people who don't like the United States, understandably. But everybody respects what NASA does. NASA is just an extraordinary brand, as we say, and I predict that the Australian Space Agency will be a fantastic brand representing your remarkable country. So we keep the pressure on. Now, time for guy in red. Then we'll come back this way. And I have to pass the microphone over. Anyway, thanks you guys. Thanks for your patience here. So it's really good. So here he goes. Guy in blue, passing to guy in red.
Good evening, Bill. Thanks for coming out late. I used to watch the show as a kid, and before...
And you're still talking to me.
That's right.
It's fantastic.
And before that, I used to watch Carl Sagan's Cosmos, Carl Sagan's a great guy, awesome guy, and just you mentioned that you knew him. I just want to know what sort of person he was.
Well, my experience, I didn't really know the guy, but I like to remind, do you know Steve Soder? He was a grad student under Carl Sagan. Now he works with Neil deGrasse Tyson at the American Museum of Natural History. I remind him every time I see him. He gave me an A on my final paper. But at my 10th college reunion, I went back and I petitioned Carl Sagan's secretary. This once again was with this paper, information storage technology. I wrote a letter, and he agreed to meet with me for 5 minutes. And I would just say in person, his manner was very much the way you saw it on Cosmos. The guy spoke in these wonderful, poetic turns of phrase. He was really something. But he said to me, I said, I'm thinking about doing this show for educating kids because I don't want us to make any more Ford Pinto cars. And he said, no, you guys, I came of age as an engineer at a time that it was depressing. We had disco giving way to the important work of Sid Vicious and the Sex Pistols. And people were wearing these amazing suits that were awful and the hair was horrible. But all that aside, he said to me, if you're doing any demonstrations on the television show, be sure you focus on pure science. He said, kids resonate. That was a verb he used. Kids resonate to pure science. And that one sentence that one meeting directed my life. So I shudder to think what other sentences Carl Sagan said to people that directed their lives. But I wouldn't be here and I wouldn't have met all these extraordinary people who built Lightsail and the people on the board of directors without that just one little moment in my life. It's amazing. Life's amazing that way. Where else am I picking? Guy in middle. Who's got microphone for guy in middle? Guys, thanks for all for your patience. This is really nice. Yes, sir.
Hi, sir. Happy to see you. My first thought is like that every movie we make, find an alien or an extraterrestrial animal, we see that it's a danger to human or Earth. And just in case we happen to find any living organism in the universe, what is our approach? Like, how are we gonna interact or say first thing?
So here's what I want to do, you guys. I want to send spacecraft to Mars to look for life. Okay? Is that what you're talking about? And I'm imagining there'll be microbes. And here in Australia, you have stromatolites, these fossilized microbial beds. If we were to discover something like that on Mars, it would change the course of history. I'm telling you. And the Lloyds of London won't take the bet anymore. They're so confident that life will be found there. And for those of you unfamiliar with this idea, Mars is smaller, cooled off faster, doesn't have an iron core spinning, so it doesn't have as much of a magnetic field, and this atmosphere was stripped off probably by the solar wind, by particles from the sun. But because it cooled off faster, it had an ocean sooner than the Earth did. So did life start on Mars? Get going, Mars was hit with an impactor, and then woo, 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 woo. Except in space there's no sound, it was just, and then it came to Earth, and then you and I are descendants of Martians. I mean, if I may, dude, that's like so out there. I mean, that would be just, if we could prove that hypothesis, it would just be extraordinary. And if it turns out that we are alone in the universe, that is just creepy. And, but it's also worth knowing. I mean, what an extraordinary time to be alive, where we stand on the verge of making these discoveries. And as you may know, when we send spacecraft to Mars or Europa, it involves space agencies around the world, instruments, software is created by people around the world. And this is a chance for humankind to work together. And for those of you who were at the Heads of Agency event yesterday, I was not kidding. Hey man, if there's an asteroid coming to hit the Earth, somebody's going to have to do something. And it's not going to be, it probably won't be people involved in sheep herd. Probably not. It will probably be space agencies. There is no evidence that the ancient dinosaurs had a space program. They might have. But if they did, it didn't work as well as it should have. And so I am so old, when I was in second grade, my second grade teacher, Mrs. McGonigal, told us, she had a big book. She read from it about the ancient dinosaurs. The reason they went extinct is dinosaurs had small brains, so the mammals took all their food and the dinosaurs died. People, come on, even she knew, she was just shaking her head. That's just lame, come on. I mean, if they're, just, okay, I'm a Tyrannosaurus. Okay, wait, I'm a Tyrannosaurus. And there's a rabbit. I mean, you could just, oh, yeah, jeez. I mean, even she knew that was horrible. So in my, not a very reasonable hypothesis, in my lifetime, it was discovered that the ancient dinosaurs were probably killed by an asteroidal or cometary impact. Just think what else we haven't thought of. Just think what, that was in my lifetime. When I was a little kid, people were not absolutely, completely, totally, absolutely convinced that there were tectonic plates. Now it's the fundamental idea in all of geology. Just think what we may find by continuing to explore space. Oh my goodness. Next question over here, yes. Yes, woman in turquoise, is that the word?
Bill, as a science communicator, I have a tremendous science advocacy heart on right now for you, so amazing. Thank you. Heart on.
Yes,
I'm embedded.
yes.
We're here for
I
the
know
science
that,
love.
It's good to know. So those two sounds are home organic. The T and the D are maybe just touch your throat, you can tell the difference, but you have the heart.
Heart.
Yeah, hot. Doing my best here on the Tyvo.
Beautiful. I'm embedded in a planetary research team, and I would like to know how best universities can work with this emerging Australian space agency, and how we can support planetary research that is fundamental to an innovative and prosperous space agency.
It's just what I say to everybody is engage people. You're a science communicator. What is the thing you liked about your favorite teacher? What is the thing you liked about your favorite professor? It's their passion. So when you go to the university and say, let's build a spacecraft and explore Mars, show how cool it is. Come on, people. We'd make discoveries. People say, why do you build this mission? Why did you build a Cassini mission to explore Saturn? What are you going to find there? We don't know. That's why we're exploring. Did you see there's a hexagonal storm on the North Pole of Saturn? For crying out loud. Do you know why there's a hexagonal storm on the North Pole of Saturn? Nobody knows. But just think what that may mean for understanding weather on our world and looking for signs of, just show your passion. You're here and you have a brand new space agency that's going to have a cool logo. And you're going to be part of the world. You're going to be even more a part of space exploration. I mean, Australia already plays this key role for having these telescopes in the southern and Deep Space Network antenna in the southern hemisphere. You're hovering, Aaron. This is Aaron Greason, our communications director at the Planetary Society. Here's Andrew Pauly, he's the young people with the social media thing that the kids do.
Like us on Facebook.
Yeah. And then here is Scott Hubbard, who's on our board. Here's the Lightsail team sitting in the front row. Please engage them. Here's Jason, our political analyst. And I would say hi to my mom, but she's not here, so. Is there anything? No, but really, stuff happens. Is it time to move on? All right. Hey, thank you so much. You are at the base. You are the citizens. You are exploring space. Together, my friends, we can, dare I say it, save the world. Thank you so much.